Hello guys, welcome to DESI ASTRO. So in this tutorial, Python for astronomy. So our objective will be to learn two things. So first is to like how to make your 2D image cutout from a fits file image. So basically 2D cutout means suppose we have an image here, okay? It is around like 800 to 800 pixel. Now suppose you want to cut image from this middle portion of this, say 400 to 700, and from 500 to 800. So like how to cut this image from a bigger picture. So this we will do using Python. And second objective is to like how to save your cutout image into fits file. So let's do it. Okay, so our first objective will be to like read your fits file. Okay, so first like read fits file. Okay, so for that you need to import your libraries. So import library, so you can from astropy dot input output import fits, and also you can import your Matplotlib. So for plotting, so import matplotlib dot pyplot as plt and import numpy as np. So this is for reading your fits file. So reading fits file, this is for plotting, and this is for your array. Now so for reading your fits file in your directory, there should be a fits file already in your directory. Okay, so I will have a fits file called r.fits. Okay, so I will type here file equal to fits dot open and give here your file name. Okay, so in my case I have file name r.fits. Okay, now run it. So if you type file here, then it will show some information. Okay, one more thing. So if you don't know how to read fits file, then you can watch my this video where I have explained the details of the fits file, that how to read it, how to plot it in a more general way. So here I will not do the various steps. Okay, so here you can see, you can also like type file dot info to see where is my image file. Okay, so in primary SDU there's my image file and has size 2048 into 4089. So now plot it. Okay, so plot it. So for that, okay, so for before that, now access your data. Okay, so access your image 2D data. So for that, put here data equal to, or maybe you can type image equal to file. So in your primary SDU there is your image. Okay, so for primary you need to give 0 index and then dot data. Now run it and type image. So here you can see that there is your 2D image data. Now plot it. Okay, so plot image. So for that type plt dot image show IMSO it's called, and pass your data points. So image, then type plt dot so, and now run it. So here you can see that your image is has been plotted, but you cannot see anything. Okay, so for that you can maybe you can add interactive control. Okay, so here add interactive control, and then type here percentage matplotlib widget, run it. Okay, so here you can see that you got here some. Okay, so zoom it, and you can see that there are some images, but it's not visible on this scale. So we have to go to the log scale. Okay, so here import from matplotlib dot colors, import log norm. Now go here, or you can create a color map, or norm equal to log norm, and run it. Now here you can okay, so here you can see that now you can see that there's like galaxies. This is galaxy, interacting galaxies, and there are stars, there are other galaxies in this system. Okay, so this much we have done. Now you want to add a color map to this plot. So for that type here plt dot color bar. Okay, and you can give it cmap equal to you can see give you can give say uh, gray. So already it is gray scale. Okay, so the same thing, yeah, so it is on the like gray scale. You can change this to chest. So what is that? Also there should be jet, not just. Okay, so it will appear like that, and you can see that now your color bar is on log scale. Okay, that's why it is the log norm. This will make your color bar on the log scale. Now this much you have done, and now you can see that your like fits image is not setting its left corner at 0 0. So we will put here origin equal to lower, and then you can see that now your image origin has been coinciding with 0 0. So this is like basic of your reading fits file. Now we want to make cutout of the image. Okay, so for that can also make here plt dot figure to separate. Now we can add cell. Insert cell below. Okay, so now you have read your feeds file, and now we want to cut it. So now make cutout of this image of size, say I want to make cutout of this image 0 to 1500 and then 0 to 600. So x 0 to 1500 and then y 0 to 1600 pixel. Now for that you need to do the following stuff. Okay, so you can, so you want this size, okay, so this would contain your image. Now you can import some other library, so you need to from astropy.nddata import cutout 2D. And then you want to also import units because you want to cut it into the pixel size, okay, image of pixel size. So you can also import from astropy.units from astropy import units as u. Okay, so this will take care of your unit. Now you can give a position, so position you can give, say position equal to, I want to give position say from, yeah, I can give from position here of 500 and then 200. Okay, so position I can give here 500 and 200 pixel in pixel scale. Now you want to give your say cutout, so cutout you want to make from the figure, so type cutout equal to cutout 2D and let's see what it takes. So it will take your data, so yeah, so you can take your image variable defined earlier and then it will take your position, so it will take a position and take your size. Okay, so size, so now we want to also give your size, so size, suppose I want to give size equal to u dot quantity, then I can give say I want to make size of say 1500 and then 600 and this close comma u dot in the pixel, okay, in the pixel space. Now so we need to close it completely, yeah, now it's fine. Okay, so now we have make cutout. So this is for like cutout for size and given position. Now this much you have done, run it. So we have, what is the error? astropy.nddata import. Okay, so some mistake I got. I think there should be capital C. So make it capital C and check it. Okay, so now it has worked out. So you can check it. What is your cutout? So type cutout. Okay, so here's your like data. Now suppose you want to see that how your cutout looks like. Okay, so for that, uh, plot your cutout image. Now for plt dot image show, and then pass your cutout dot data in that. You can plot it, run it. So here you can see that there is your cutout image, but it is not showing properly. So pass here uh, log norm equal to, norm equal to norm equal to log norm, then origin equal to lower, and then cmap equal to, you can pass it, say jet. Now run it. Okay, you can type here plt.show. Now run it. What is the mistake? Oh. Okay, so now you can see that here is your image and has been cut out to this. I think there is some mismatch in x and y coordinates. So here basically your 1500 is your yeah. So how much we have got it? 600 pixel. So this is 600 and this is, you can make it say 500, make it. Okay, so here it is 600 to 500 size. Can also increase, so you can make it to say 700. Okay, so it has become 700. Can make it much larger. You can go to 1200. Yeah, so here you can see that basically your position, this is your like y x pixel. Okay, y x pixel, and this is your xy pixel, xy pixel for center, and yx pixel for cutout axis. Okay, so there's a reverse. So this way you can make cutout image. So I hope you got the idea that how to make cutout image from a 2D fits file and how to show it. Now you can also make changes some with that. You can make say you can make it say 600. So this become your 600. So this way you can make your cutout image. So I hope you got the idea that how to make 2D cutout image from a fits file and how to show it using astropy.nddata import cutout 2D. So basically I can revise once again. So we have imported some libraries. I have read a fits file. I have uh, I have plotted image of the 2D data using image IMSO, and then I have imported 2D cutout image, then imported unit for the pixel scale, and then I have defined the position. Basically means center of the image, and then I have given some size x, y, and y sizes in the pixel scale, and then I have simply plotted uh, cutout image using I using image flow, and I've given some. You can also put your color bar. So plt dot color bar and run it. So it can also show your color bar. So I've shown the image using color bar and some uh, color maps. You can make it gray, so it will appear like that. So this way you can do the stuff. So I hope now you have got a clear idea that how to read the fits file and how to make a 2D cutout image from this. So thank you. And in next video I am going to show you that how to save cutout image into fits file and also its header. So thank you.